Have you ever wondered how your phone survives a hot day or a freezing night? It's thanks to something called temperature cycling, a brutal test for electronics. Imagine putting your gadgets through the most extreme heat and cold over and over. That's what engineers do to make sure our electronics are tough. Temperature cycling is like a stress test for integrated circuits, the tiny brains inside our gadgets. By rapidly changing the temperature, we can see how these chips hold up under pressure. This is super important because different materials expand and contract at different rates when heated or cooled. Think about it like this. Imagine a metal lid stuck on a glass jar. If you heat the lid, it expands faster than the glass, making it easier to twist off. The same thing can happen inside an IC package, causing connections to break or short circuit. Temperature cycling helps us find these weak points before they become a problem. This testing process is crucial for ensuring the reliability and longevity of our electronics. Without it, our gadgets would be much more likely to fail in everyday use. Reliability testing is like putting ICs through boot camp. We subject them to extreme temperatures, sometimes swinging from minus 55 degrees Celsius to 125 degrees Celsius in a matter of minutes. This simulates the kind of conditions they might experience in the real world, from a hot car dashboard to a freezing cold airplane cabin. These rapid temperature changes can cause materials to expand and contract, putting stress on the delicate connections within the IC. Over time, this can lead to fatigue, just like bending a paperclip back and forth until it breaks. By cycling the temperature, we can accelerate this process and identify potential failure points early on. Think of it like testing the suspension on a car. We drive it over bumps and potholes to make sure it can handle the stress of everyday driving. Temperature cycling does the same thing for electronics, ensuring they can withstand the rigors of real-world use. This rigorous testing is essential for identifying design flaws and material weaknesses, allowing engineers to make improvements and ensure the long-term reliability of their products. Quality assurance is all about making sure that every single IC that leaves the factory meets the highest standards. Temperature cycling plays a vital role in this process by weeding out any weak links in the production line. By subjecting a sample of ICs from each batch to rigorous temperature cycling, manufacturers can identify any systemic problems that might be affecting the entire production run. This ensures that only the toughest and most reliable chips make it into your devices. It's like a final exam for electronics. If a chip can survive hundreds or even thousands of temperature cycles without failing, it's a good bet that it can handle whatever real-world conditions you throw at it. This meticulous approach to quality control ensures that consumers can have confidence in the products they buy, knowing that they have been designed and manufactured to the highest standards. Section 4 Industry Standards, setting the bar for toughness. Just like there are building codes to ensure the safety of structures, there are industry standards for electronics reliability. Organizations like JEDEC and MIL-STD 883 set the bar for temperature cycling tests, defining the specific conditions and durations that integrated circuits must endure. These standards ensure that electronics from different manufacturers are tested to the same rigorous standards, providing a level playing field and ensuring a minimum level of quality and reliability across the industry. It's like having a universal set of rules for a competition. Everyone knows what's expected, and only the toughest competitors can come out on top. By adhering to these standards, manufacturers can demonstrate the robustness of their products and give consumers confidence in their purchases. Section 5 Real-world examples, from smartphones to spacecraft. The importance of temperature cycling is evident in a wide range of applications, from the smartphones in our pockets to the spacecraft exploring our solar system. For example, smartphones are subjected to extreme temperature variations, from the heat of a summer day to the frigid temperatures of a winter night. Temperature cycling ensures that the delicate electronics inside can withstand these extremes without skipping a beat. On the other hand, spacecraft experience even more dramatic temperature swings as they travel through the vacuum of space, exposed to the intense heat of the sun and the frigid cold of deep space. Temperature cycling is crucial for ensuring that these critical systems can operate reliably in these harsh conditions. These examples highlight the importance of temperature cycling in ensuring the reliability and longevity of electronics across a wide range of applications, from everyday consumer products to mission-critical systems. Section 6: Temperature cycling, the unsung hero of electronics. Temperature cycling might not be the most glamorous aspect of electronics design and manufacturing, but it plays a vital role in ensuring that our gadgets are reliable, durable, and perform as expected. Think of it as the unsung hero of the electronics world, working tirelessly behind the scenes to ensure that our devices can withstand the rigors of everyday use. By subjecting integrated circuits to extreme temperature variations, we can identify weaknesses, improve designs, and ensure that only the toughest and most reliable chips make it into our hands. So next time you pick up your smartphone or turn on your laptop, take a moment to appreciate the role that temperature cycling played in making it all possible.